Welcome to this beginner's guide on the Observer and Publisher Subscriber design patterns in Unity 3D, essential tools for robust game development. These patterns enable one-to-many dependency relationships between objects, promoting loose coupling and modularity within your game code. The core idea is that a subject or publisher maintains a list of its dependents, known as observers or subscribers, and notifies them of any state changes. This notification typically occurs by calling one of their methods, ensuring the publisher doesn't need specific knowledge of its subscribers. Let's define some key terms. The subject or publisher is the object that holds the data and notifies others of changes. Observers or subscribers are the objects that listen for these changes and react accordingly when notified. Loose coupling is the primary goal, allowing objects to interact without tight dependencies, making your system more flexible. Events are the specific actions or occurrences that the subject broadcasts to its observers. In C#, delegates and actions are features used to implement this event mechanism, allowing observers to subscribe and unsubscribe. The benefits of using the observer pattern are significant, starting with enhanced decoupling between objects. This promotes a more modular design, making your code easier to manage and understand. It also improves reusability, as observers are not tightly bound to a specific subject and can be used in various contexts. Scalability is another key advantage, as adding new observers or modifying existing ones becomes much simpler without affecting the subject. Maintainability is greatly improved, reducing the risk of introducing bugs when modifying your system. Finally, it offers flexibility, enabling dynamic systems where publishers and subscribers can be added or removed at runtime. In Unity, you can implement the observer pattern using C# events and delegates, or Unity's own Unity event class. First, define your subject. Create a C# script that holds the data to be observed and declares an event using the event keyword. This subject script will also contain a property that, when set, triggers the onChange event to notify observers. Next, create your observers. These scripts subscribe to the subject's event and contain the logic to execute when the event is triggered. The handleChange method will then process the message received from the subject. Crucially, always remember to unsubscribe from events in onDestroy to prevent memory leaks. Unity events offer a powerful alternative, allowing you to connect functions visually in the inspector without writing additional code. They are excellent for rapid prototyping and visual scripting, supporting up to 4 arguments to pass data. The observer pattern has numerous practical uses in game development. For instance, updating UI elements like health bars or score displays. It's also perfect for managing game events such as player input, collisions, and triggers. You can use it for unlocking achievements when specific conditions are met, or triggering audio and visual effects. Consider a health management system. The player health script acts as the subject, maintaining the player's health. When health changes, it triggers an onHealthChanged event. Observers like a health bar script update the UI, and a sound manager script plays a sound effect when damage occurs. For beginners, start simple. Implement a basic version to grasp the core concepts before tackling complex scenarios. Leverage C# delegates or actions for defining events and handling subscriptions, as they are fundamental. Remember to always unsubscribe from events when an observer is no longer needed to prevent memory leaks and unexpected behavior. The publisher-subscriber pattern is closely related but introduces a message broker or event bus. This broker relays messages from publishers to subscribers, providing even looser coupling than the direct observer pattern. Use the observer pattern when subjects and observers have a direct relationship and frequent communication is needed. Opt for publisher-subscriber when high scalability and extremely loose coupling are required, often with components having no direct knowledge of each other. Mastering these patterns will empower you to build flexible, modular, and maintainable systems in Unity. By understanding these core concepts, you can create more organized and scalable games. Thank you for watching this guide on the Observer and Publisher Subscriber patterns in Unity 3D.